Makemake is a fascinating celestial body that resides in the distant regions of our solar system. As one of the 5 officially recognized dwarf planets, it offers a unique glimpse into the characteristics of objects that lie beyond Neptune in the so-called Kuiper Belt. This introduction delves into Makemake's discovery, physical characteristics, orbit, and its significance in our understanding of the solar system. Makemake was discovered on March 31, 2005, by a team of astronomers working with the Palomar Observatory in California, led by Mike Brown. This discovery was significant as it added to the growing number of objects found in the Kuiper Belt, a region beyond the orbit of Neptune that contains many small icy bodies. Makemake's discovery was part of a search to find more dwarf planets that could help scientists understand the formation and dynamics of the outer solar system. The name Makemake is derived from the god of fertility and creation in Rapa Nui mythology, the indigenous culture of Easter Island. The name was suggested by the discoverers and approved by the International Astronomical Union. This naming is in line with a tradition in which celestial bodies are named after mythological figures, especially those related to creation, fertility, and the natural world. Makemake's discovery came just a year after that of Eris, another dwarf planet, and shortly before the reclassification of Pluto from a planet to a dwarf planet in 2006. This series of discoveries helped to redefine our understanding of what constitutes a planet, and sparked debates within the astronomical community about how to classify objects in the solar system. Makemake is relatively small in size compared to the planets in our solar system, but it is still significant in its own right as a dwarf planet. It is the 3rd largest known trans-Neptunian object in terms of size, following Pluto and Eris. However, compared to the planets, it is minuscule. Its diameter is approximately 1,430 kilometers, roughly 2/3 the size of Pluto. Despite its small size, Makemake is thought to have a relatively high albedo, meaning it reflects a significant amount of sunlight. This is due to the presence of a surface covered in frozen methane, ethane, and possibly nitrogen. These materials give Makemake a reflective, icy surface, making it one of the brightest objects in the Kuiper Belt. Makemake's surface is also believed to be covered by a layer of frozen methane, which may explain its brightness. The surface temperature of Makemake is extremely cold, with estimates ranging between 243 degrees and 223 degrees. These low temperatures are typical for objects in the outer reaches of the solar system, where sunlight is much weaker than it is closer to the sun. One of the key features of Makemake is its lack of a detectable atmosphere. Unlike Pluto, which has a thin atmosphere that expands and contracts as it moves through its orbit, Makemake seems to have no such atmospheric layer. This is one of the reasons why Makemake's surface remains so cold and stable. Makemake is part of the Kuiper Belt, a vast region of the solar system that lies beyond the orbit of Neptune. The Kuiper Belt contains many small icy bodies, some of which are considered dwarf planets. Makemake's orbit places it at a distance of approximately 6.8 billion kilometers, about 4.2 billion miles, from the Sun, which is about 45 astronomical units, AU, away. For comparison, Earth is about 1 AU from the Sun. Makemake's orbit is somewhat circular, but also slightly inclined relative to the plane of the solar system. It takes approximately 305 years for Makemake to complete one orbit around the Sun. Due to its distance from the Sun, Makemake's orbit is extremely slow, and it moves at a relatively low speed compared to planets closer to the Sun. At its closest point to the Sun, perihelion, Makemake is about 38 AU away, while at its furthest point, aphelion, it is about 52 AU from the Sun. These distances place Makemake in the outer reaches of the Kuiper Belt, where objects are much colder and more distant from the Sun's influence. Makemake's orbit is also interesting because it is relatively stable and does not intersect with the orbits of other large objects in the Kuiper Belt. This stability suggests that Makemake has likely been in its current orbit for billions of years, and that its position in the solar system is well established. In 2015, astronomers discovered a small moon orbiting Makemake, designated S 2015-13364721. This moon is relatively small, with a diameter of about 175 kilometers, 109 miles, making it one of the smallest moons discovered in the outer solar system. The moon is in a relatively distant orbit around Makemake, and its discovery was significant because it provided further insights into the dynamics of objects in the Kuiper Belt. The moon's orbit is relatively stable, and it is thought to have been captured by Makemake's gravitational field. The presence of this moon helps to confirm that Makemake is a sizable and gravitationally significant object in the outer solar system. However, due to the vast distance between Makemake and Earth, very little is known about the moon's composition and surface features. It is worth noting that the discovery of moons around dwarf planets like Makemake adds to our understanding of the complexity and diversity of objects in the outer solar system. The study of these moons may reveal more about the formation and evolution of the Kuiper Belt and its objects. Makemake is classified as a dwarf planet by the International Astronomical Union, IAU, a category that was officially introduced in 2006 after the reclassification of Pluto. According to the IAU's definition, a dwarf planet is a celestial body that orbits the Sun, has sufficient mass to maintain a nearly round shape, but has not cleared its orbit of other debris. This last criterion distinguishes dwarf planets from full-fledged planets, which must have cleared their orbits. In addition to Makemake, other recognized dwarf planets include Pluto, Eris, Haumea, and Ceres. While these objects share certain characteristics, such as their small sizes and their locations in the outer solar system, each one has its own unique features that make it interesting to astronomers. Makemake, like Pluto, has not cleared its orbit of other objects. It shares its orbit with other Kuiper Belt objects, many of which are similar in size and composition. This is one of the reasons why both Pluto and Makemake are considered dwarf planets rather than full planets. Despite its small size, Makemake's classification as a dwarf planet places it in a category of objects that are important for understanding the history and evolution of the solar system. Dwarf planets like Makemake provide valuable information about the early solar system and the processes that led to the formation of the planets. Makemake's location in the Kuiper Belt and its status as a dwarf planet make it an important object of study for astronomers and planetary scientists. The study of Makemake can provide insights into the formation of the solar system, particularly the outer regions, where the planets and smaller bodies formed billions of years ago. One of the most significant aspects of studying Makemake is its composition. The presence of methane and other volatile compounds on its surface suggests that Makemake may have a similar composition to other icy bodies in the Kuiper Belt, such as Pluto and Haumea. By studying these materials, scientists can learn more about the processes that shape the outer solar system and the chemical composition of objects that formed far from the Sun. Additionally, Makemake's lack of atmosphere offers an interesting contrast to other dwarf planets, such as Pluto, which has a thin, seasonal atmosphere. The study of Makemake's surface conditions and the absence of an atmosphere may help scientists understand the role that atmospheres play in shaping the environments of distant solar system objects. Makemake's moon also adds to its scientific significance. The presence of a moon offers opportunities to study the dynamics of satellite systems in the outer solar system. By analyzing the moon's orbit, scientists can gain insights into the gravitational interactions between Makemake and its moon, as well as the history of how the Moon was captured. Due to its extreme distance from Earth, observing Makemake is a challenging task for astronomers. However, thanks to advanced telescopes such as the Hubble Space Telescope, scientists have been able to study Makemake and gather important data about its size, shape, and surface composition. Future space missions to the outer solar system may provide even more detailed information about Makemake and other similar objects in the Kuiper Belt. Currently, the most detailed images of Makemake come from Hubble, which has been able to capture high-resolution images of the dwarf planet, allowing scientists to study its surface and make more accurate measurements of its size and characteristics. However, due to the vast distance between Makemake and Earth, direct exploration of this distant world is not currently feasible. Makemake is a fascinating object that lies in the distant reaches of our solar system. As a dwarf planet in the Kuiper Belt, it offers valuable insights into the nature of objects beyond Neptune and the processes that shape the early solar system. With its icy surface, lack of atmosphere, and the discovery of a small moon, Makemake continues to be a subject of interest for astronomers and planetary scientists alike. While much remains to be learned about Makemake, its discovery has already expanded our understanding of the outer solar system and the diverse range of objects that inhabit this far-flung region. As technology advances and new observations are made, Makemake will continue to provide valuable data that will deepen our understanding of the solar system's formation and evolution.